In this lecture, I will discuss one question of uniform circular motion in detail. And if you guys understand this, then you can answer others' questions also. Okay, we'll take in detail. Now, the question is this, that there is a string and one stone is tied and it is made to go in a horizontal circle. So, if you can understand, then horizontal circle, as I explained, it will be circle like this, right, in a horizontal plane. If you see from the top, it will be something like this, right? One string and is going in a circle. This is called bird eye view. So the question is, one is stone is tied in a string and it's going in a circle, horizontal circle. Now the questions are this, that whether is the, so it is made to go in a horizontal circle with constant speed, so in uniform circular motion. Okay, it is made to go in a circle of constant speed, that is uniform circular motion. The question is first, whether the stone velocity is variable or uniform. So as we talked about, let us say the stone is going like this. If the stone is here, the velocity is in this direction. If the stone is here, the velocity is in this direction, and the stone is here, the velocity. So of course the velocity is variable, okay, because velocity is a vector quantity. Speed is not variable, speed is constant. Now the second part asks, what is the whether the acceleration is variable or uniform. Acceleration. Now since it's an example of uniform circular motion, if you remembered, then acceleration is always towards the center, right? Now same way, acceleration direction is also changing, right? It was pointing in this way, then it was pointing in, of course it is pointing toward the center, but if you have a center, there are many possible direction to reach it, right? To the same center. So acceleration always points towards center, but its direction is like this, then it's like this, so it is again a variable, it's not uniform. The third question is, what is the direction of acceleration at any instant? So direction of acceleration, so it is always towards the center, right? Now the fourth question is, what force does provide the centripetal force? So which force or what force now, to answer this question, we talked about, like, centripetal force is not a new kind of force. So as you will rotate the string, the stone, the string will become tight and tension will be developed. So there will be tension T. This T is acting on stone, this tension, and this will provide the centripetal force. Okay, so this tension is acting on the stone. Now, so this force, tension force, provide the centripetal force. Now the next part of the question is, Name the force and its direction. Name the force and its direction which acts on the hand. Now this is very conceptual question, right? So what happens? See, this tension is acting on the stone. Now what happens? When you make the stone go in a circle, this tension is acting on the stone, right? According to Newton's third law, this is suppose your hand. Okay, I am just drawing. This is your hand. Okay, hand ka grip. Okay, this is the grip of your hand. So according to Newton's third law, if this tension is acting on your hand, the tension must be in this direction. Okay, this is your hand ka grip. So this tension is acting on your hand, and this is an example of Newton's third law. Okay, it is just like you can imagine every action has equal and opposite reaction, and reaction acts on different body. So if your hand is somehow pulling the stone with tension T, the stone is pulling your hand with tension T. Okay, this is now again, this is a conceptual, just try to understand it, it will be readily output. Right. Now in the same question, okay, what is work done by centripetal force in uniform circular motion? Now we'll generally student give very wrong answer. They say that in a circular motion displacement is 0, so work done is 0, but that is a wrong answer. So what is work done by centripetal force in uniform circular motion? The answer comes out to be 0. We'll try to understand it. Okay, this is the answer. Now work done is force into displacement into cos theta. Right. Now if a body goes in a circle, so centripetal force on the body we are considering, this is tension, so this is our force F. This is force F. Okay. Now velocity is always tangential. What is the angle between tension and velocity? This is along the string, this is tangent, this is 90 degree. Theta is 90 degree. Now what is velocity? Velocity is nothing but displacement by time. So whatever is the direction of velocity will be same as that of displacement. Okay, because velocity is a vector quantity, displacement is vector quantity, velocity is displacement by time. So this force is nothing but in our case tension. This displacement we are writing S, which is along the velocity. Okay, because velocity is displacement by time. This theta turns out to be 90 degrees, so W equal to Fs cos 90 degree. We all know that cos 90 degree is 0, so work done is 0. Okay, Now again try to understand at any point, at each point this force and velocity will be perpendicular, and because of that you can also means add one more thing here. Power delivered by your hand will be work done by time, or power delivered by the tension is work done by time. Work done is 0, so power delivered by this centripetal force will be always 0. So what is the power delivered by centripetal force in uniform circular motion? The answer is 0, because theta is 90 degree. Now there is one more question which is asked relative to this, is whether centripetal force and centrifugal force are action and reaction pair. Okay, so I am putting this as a different question, whether centripetal force and centrifugal force are action and reaction, like what we talk in Newton's third law. So let us try to understand it. So we agree that if a stone is going in a circle, right, it will feel a centripetal force inside. This stone will feel a centripetal force inside. I am writing okay, Fc to be centripetal force, it is inside, and the same stone will feel a centrifugal force outside. I am writing Cf for centrifugal force. Now whether centripetal force and centrifugal force are action and reaction pair, that is a question. Now if you go to Newton's third law, it says that to every action there is a equal and opposite reaction, and action and reaction acts on different bodies. Now it turns out that if you say that they are action and reaction pair, then it is very wrong concept, because centripetal force is also acting on the stone, centrifugal force is also acting on the stone, so they are not action reaction pair. Action and reaction will act on different bodies, not on the same body. So it turns out that that is not true. Okay, fine. Okay, if you guys then we'll just add one more thing to it. Okay, so this is done. Then if I ask you, in uniform circular motion, I am writing UCF, uniform circular motion, kinetic energy varies and momentum varies. We'll end up with this, right? So if you remember, kinetic energy is half mv square. Now this is a speed, this is a scalar quantity, mass is a scalar, speed is a scalar, right? So it turns out the speed remain constant in uniform circular motion, v is constant, so k remain constant. Now if you remembered momentum, then momentum is product of mass into velocity, right? Now in uniform circular motion we understood that velocity direction changes continuously with time, it is tangential. So momentum is a vector quantity, this is scalar, this is vector, so this is a vector quantity. So momentum will vary with time. Momentum direction is nothing but the velocity direction. Now I guess if you guys can understand this question, you guys can do the questions of uniform circular motion. Thank you.